I guess without taking any more time, I'd probably just want to get started with intros. So as I said, my name is David. So I guess we can go around the room, starting with Abuzar and then Wale. So
hi,
just
everybody.
Just tell us your name, and what company you work for, and what you do. Yeah.
All right. Thank you, David, for starting this off. So I'm Abuzar. I'm co-founder and CEO at Pastel. At Pastel, we are a tech startup. We are based out of Lagos in California, and we build AI-based solutions for businesses and enterprises. Some of our solutions include transaction monitoring, user risk monitoring, and credit risk assessment. Our team's background is in AI and data science from Stanford, MIT, and Carnegie Mellon, and that's why we're interested in this space. So thank you, David, for inviting us.
Yeah, thanks for joining. So Wale, over to you now.
Thank you, David. My name is Wale Akanbi, CTO co-founder of Aella. At Aella, we provide financial services to everyone that is underserved. We started with credit, and we've morphed into a full digital bank, offering different financial services to everyone, building a smarter bank for even the underserved. That's just basically me and us, generally.
Yeah, and finally, Stephanie.
Hi, I'm Stephanie. I'm a data analyst at Paystack, currently based in Edinburgh, previously Dubai. My background is in data science as well as data analysis. So previously I was working on big data platforms for the Dubai government agencies, where I worked on models related to traffic incident prediction, taxi demand prediction, and also some sentiment analysis of customer support tickets. Most recently, I've been working on machine learning applications for fraud detection at Paystack.
Nice. So I think we have a pretty diverse group of panelists, and as we've already said, we have a bunch of questions for them, and hope that they can share as much of their knowledge as possible within the time that we have. So I guess just kind of going straight into the topic for today. I guess we could start by just setting the scene for what fraud is. So in very simple terms, fraud will be defined as like a criminal deception intended to result in some sort of financial gain. So usually it's very key that there's some deception involved, and then usually there's some financial gain involved as well. And I guess like in a perfect world, there'll be absolutely no fraud. But I mean, we don't live in a perfect world. And to be honest, some of us kind of rely on the existence of fraud for our careers, or our careers are kind of dependent on the existence of fraud. But I guess to start off, a lot of statistics suggest that for companies that launch, especially within Africa, a lot of your earliest users will be fraudsters. Like it's very, very likely that the first set of people who will onboard will be people trying to find the limits of what your system can do, and just basically trying to do like a mini stress test. So the first question is really to, I guess, to Wale. So for companies that are in their early days right now, what would you recommend kind of as a bare minimum for fraud prevention or fraud detection? You could speak specifically for financial services, as I know that's your domain, but you could also just answer the question for just like tech-enabled businesses in general. So what's bare minimum, and what should be the starting point?
Okay, thank you, David. I think for me, I feel like the starting point would be having like a web application firewall, like a WAF, right? There are a couple of them that are near free, right? Having that can actually help reduce a couple of things, but not all. I would say having a bare minimum or a basic fraud prevention monitoring solutions, right? There are a couple of them online that one can have for the size of I'm starting today, then have it today. Don't wait till tomorrow to have it, right? If you are using any of these stores, there are so many plugins that you could use for that, right? So I would suggest that you start immediately. Don't wait till like tomorrow to get started and say, you know what, nothing is going to happen on day one. From experience, and anybody that has done fintech, I know that day one is always the hardest, to be very honest. But again, as you ease in, then it becomes more difficult. But I think you should start from day one. Have a simple web application firewall and then some other monitoring solutions. So for the second one, which is what should be the starting point, right? I think having a basic KYC and a very good onboarding process is very key for users. I would say for B2B, might not be as difficult as B2C, because B2C is all over the place. You have to have so many things to guide your entire process over and over again, one after the other. So I would say that have a good onboarding process, have a good KYC stroke KYB, right? Know your customer stroke, know your business process in place, a very good one. I would suggest that you consult people that probably have experience in that area, or also third party, right, that offer a very good onboarding process. I think that's just what would be my basic bare minimum and starting point.
Yeah, thanks a lot, Wale. So definitely, I agree very strongly on onboarding and just identity verification. Because as I defined earlier, fraud usually involves like some form of deception. So a lot of the fraudsters' kind of strength is in anonymity. So basically, having very good KYC, KYB, onboarding and identity verification just helps remove that anonymity completely. Abuzar, I wonder if you have anything to add to what Wale has already said.
Absolutely. So yeah, those were actually all great points by Wale and yourself, David. In addition to what you guys mentioned, I'd suggest that obviously KYC is extremely important. So make sure that you do your customers' KYC and KYB, but also do not just rely solely on KYC and KYB, because on their own they cannot be enough. Some other specific suggestions that I can share is implementing some transaction rate limits in the beginning, making sure that you start with some sort of pilot and slow release of the product instead of going full release immediately. Also, if you can, try to plug some of the loopholes and gaps in your system. So for example, some of the ones that comes to mind is make sure that you're stopping people from using multiple devices to conduct the same transaction, for example. Make sure that over holidays and weekends you have somebody who can monitor transactions. Especially pay attention to small amounts of money that are being moved, because usually fraudsters will use small amounts of money to test your systems before they move larger amounts of money. Also pay attention to when your users are signing up. And if you, for example, get an upsurge in the number of users, don't just assume that that's users who want to use your system the right way. So, make sure that you dive deep to understand those users. There are, in Africa, especially in Nigeria, for example, there are groups that systematically target any new product to test the loopholes. And so that's why you need to stay ahead of that curve to at least make sure that you plug in some of those loopholes. And then lastly, I would agree with Wale that my recommendation is to use a third-party service from the very beginning, because you can never really guess and predict what sorts of fraud you will be hit with. And it's like almost a losing game to be just predicting, to guess, what sort of fraud cases will happen to you. So that's why it's I would also recommend using a third-party service even from the first day that you're launching.
Yeah, I think that we covered all bases there. And I think we're already kind of deeping into a conversation we're going to have later on about whether to build or buy fraud solutions, but I guess we'll just wait till we get there. Thanks a lot, Wale and Abuzar. So just as a kind of follow-up, there were a lot of mentions of transaction limits. I think now I'm going to reference regulation more specifically, so maybe even in fintech specifically, right? Usually there's transaction limits that are recommended by regulation, right? You're expected to only have a certain number of transactions. Your customers are only allowed to have a certain balance, or they can only do a certain amount of transactions on a daily basis, or maybe over a rolling period of like a month, right? How would you approach interpreting like the regulation, the very strict or static rules that the regulation has put forward, and kind of incorporating that into your system? Because I know that there's always that balance that has to be struck between compliance with regulation and usability, the experience of the customer and things like that. So yeah. So who wants to go first on this one? I think. Wale, do you want to start us off?
Yes, I guess I'll just take it.
Yeah.
I think the thing is, for any business, you have to start somewhere, right? And I strongly believe that the rules set by regulation, right, is a good place to start. Just like you said, things around probably keeping a certain balance, you can't go above a certain threshold, and all the likes are just good places to start, right? And then you can build your own path from there. One of those things that we noticed was that, getting started and, doing some form of working with those kind of tier system, the issue is users that are fraudulent or potential fraudulent customers are also aware of these regulations, right? So you are fighting a battle where they already know the answers, right? They find ways around it. That's the point of deception in the first place. So they find ways around it and they know the rules. So the best thing that you can do is create additional rules, right? Create a more dynamic one where you begin to set some form of logic around things, where if something doesn't work one way, it has to do the other one. So I think you can just have to more or less like build into that dynamic path, but you can start with the bare minimum, which is what the regulators have set. I think one thing that we also saw was, starting from all of those parts, and then we felt like everything was fine. Test system, you need to have XYZ before you can perform this kind of transaction. You need to do all of these things. Then we looked at it and saw that the rate of transactions that we're seeing and some workarounds in terms of patterns that we're seeing made us move from more or less like annual review to quarterly to monthly to weekly to hourly and then to minutes, right? And then to seconds that we can't even keep up with, where we had to build systems to kind of undo those kind of parts. But one thing I want to let us know is fraudulent customers also understand and know this kind of static limits, right? That has been set by regulators.
Yeah, that's a really good way to put it. So I don't know, Abuzar, if you want to add anything, but I just wanted to highlight that we're going to try to transition from the conversation around static limits and whether or not they're effective, right? I know Wale has gotten ahead of us and has talked about how we should just choose dynamic rules instead. But I wanted someone to just speak a little more on how effective those static rules were, because as you said, like in the beginning, you had to start out with those. Like, can you speak a little more on how effective were the static rules in the first place? Before we move forward.
Is that for me or for Abuzar?
Yeah, for Wale. Yeah, for Wale. Just
Okay.
yeah. So, and then Abuzar can answer as well. But yeah, Wale, you start.
That's absolutely fine. So for the static limit, one thing that we saw was transactions were fine, right? At the beginning, you begin to see, I think just like Abuzar raised earlier, you begin to see normal transactions. Users start from there, starting with those, complying with those rules, right? Until when it's time for them to more or less like go around those rules, right? You begin to see some upsurge in accounts, more or less like identity theft. You begin to see so many people, like a single device, opening 10 accounts, 40 accounts, 100 accounts, and then they become dormant, right, within the system. So they just open it, they don't perform any transaction. They just want to be sure that, okay, we are successful. So they've complied, they've provided all the, for Nigeria, for example, BVN, NIN, means of ID, could be driver's license, voter's card, they've complied. So more or less like they've moved from tier 1 of not having anything BVN to tier 2, and then even complying fully to even KYC in terms of address, right? They've done everything, and then they become dormant within the system. And then, over and over again, things begin to come up where you begin to get, chargebacks. You begin to have complaints of, hey, who opened this account in my name? You begin to have a lot of other things that come in place. So I would say static limit is fine, but again, you have to go beyond that, right? Into how would I call it now? It's effective to some extent, just to answer the question more directly, right? It's effective to some extent, but you can't fully rely on it, right? You just have to do more. You have to do more.
Yeah. So I think on you've already started the conversation about doing more. So I think we will just we'll just bite and go with it. So there's the starting point, which you've already established is with the static rules. But how do we now go from static rules to more dynamic rules, right? like one answer that I can already suspect will be something involving data. And I guess like this is where like everybody now gets to kind of contribute. Your decision making is only as good as the data that you have. If you've already been running on static rules up until that point, how do you now get the data that you need to make more dynamic decisions, or like basically where do we go from here? And I think this is more open to every single person, every single one of our panelists. So I don't know who wants to start first. Abuzar, do you want to kick us off of this?
Absolutely. Yes. So, actually on the previous question, I agree with Wale that a lot of the rules, especially the regulatory rules that we have, those are the bare minimum that's required, but they are not enough to stop fraud. So how do you now go from that to a system that actually can detect the types of fraud that you are expected to be hit by? To that end, there are different systems that you can implement. For example, you can start with, again, you can take the static rules and make them more complex. So for example, you can add more variables to the rules that you set. That's one basic way to deal with it. So for example, you can set rules that say, if a transaction happens at this time, if the amount is like this, or if the age of the account is this, if the device that is used is such, then for example, flag or block this transaction, right? So you can go to those kind of more sophisticated rules. But those, again, my argument would be that they are not enough, where you need to then transition to a more intelligent solution that can learn in real time. And that's where AI and ML comes from, which is you can build systems that can ingest large amounts of data on device, on user behavior, on transaction, on networks, and then ingest that and then make decisions and predictions on new sets of transactions that you see. So that is where AI and ML comes into play, where they can take into input from all of these different variables and then make decisions on whether a transaction is fraudulent. Obviously that's the state of the art, where that these are intelligent systems that can learn in real time, that can help you stay ahead of the fraud, which is why we'd recommend those over like more static rules, regardless of how complex those rules are that you set. But happy to dive into details of that. But before that, obviously Stephanie and Wale, you guys also probably have a bit of experience here. So
yeah, I was going to say. So Stephanie, if you have any just proposed solutions for a company that has been using static rules up until a certain point, like how do we make that transition into a more dynamic system? So yeah, what are your thoughts?
So I'd say the most foundational step is just ensuring your data completeness and accuracy as well. So before diving even into AI or machine learning, just having a very, very good understanding of your data. What is it covering? Is it comprehensive? Is it accurate? Are there any further data points that you can also add into the system? So as a data analyst, I've kind of seen some scary AI in the past in terms of people who just want to ship out a product quite quickly without actually verifying that what they're doing actually makes sense. So that's the primary kind of element of it. But this can also be done in tandem to shipping out an AI kind of model as well. So having people who are partnering up with one another. So one person responsible for kind of the data completeness and accuracy, and another one who's forward thinking about what sort of models could be implemented, what sort of data do they need, and both of them in tandem working to make sure that whatever solution that they implement, there's a level of preparedness there already. We already talked about minimum standards and how regulation can inform what those minimum standards are. But the other thing that regulation doesn't fully cover is what's the nature of your business? How are your customers kind of transacting? What sort of fraudsters are you attracting into your business? There's no way for regulation to know that completely. They're catering for allowing as much transactions to occur in a non-fraudulent fashion as possible. So they're trying to open up the playing field, and then it's your job to essentially refine that you've got a good level of so a very minimum number of people who are being blocked from transacting normally on your platform. So it's just putting in those levels of monitors and your KPIs as well in advance, so that you can ensure that the fraud ratio is low, the number of fraudulent transactions compared to your overall transaction count, without declining too many transactions either. Because the danger as well is that if you decline too many transactions, then you basically impede normal transaction behavior. which then means that it's more difficult for you to identify or implement a model because you've blocked so many transactions that you can't actually verify what truly is fraudulent, what's a false positive, what's a false negative.
I think we're okay. Wale,
Just to quickly add to that, right? So I think again, just giving more practical examples, we moved again from static rule way before. But one thing that we noticed was, having set up all those things and then moving into a user cannot perform more than a certain number of transfers within a few minutes, right? And then more or less like group of people within a single area not being able to transfer or make transactions that like of some sort. So one thing that we noticed was that, within our system, we just saw that a lot of accounts were getting flagged, right? False positive, almost like 30 minutes, like very early in the morning. And then we just saw close to 100 accounts were flagged within just 30 minutes. And then over and again, we had another 50 within 5 minutes afterwards. So we kind of like, the team went into diving into what was going on and why is the system flagging some of these things. Of course, that period, we just had like frequency, location, and just a couple of things, a couple of rules that we've set that was changing over time. But one thing that we noticed was that, people attended the same event, right? And lucky for us, we had a lot of customers that were attending that kind of event together. And, they were making transactions, we were flagging their accounts. And for no reason, we flagged, I think, close to 150 accounts within just first, I think 20 or 30 minutes in all. And it was false positive for all the accounts. Again, B2C, everybody was all making noise. It's one of those things that you have to kind of like deal with, right? Hence why we had to see that, this is not sustainable. We had to unfreeze, go into more rules and all of those kind of things. They were not just sustainable over time. You can't keep up with those kind of data points that you have to set over and over again and start chasing around. It never ends, right? Hence why transition into ML, right, is one of the best decisions that we've kind of made over time.
Yeah, amazing. Wow. I feel like the conversation has a life of its own now. Almost like you don't need me. But I guess another opportunity for us to go around the room. So speaking more specifically, what kind of data points have you worked with in the more dynamic sense, and what kind of data points have informed whatever models that you're working with? So I think we can start with that. Just give us an idea. What kind of things are we talking about here that were very informative to just like how you approach things now?
Okay, so I think I'll just pick the basic ones, right? So imagine you perform a transaction 1 minute in Ikeja, right? And next minute you are performing it in New York, right? And then, you begin to see transactions bouncing around from the same device, right? In so many cases. You have set up a rule of IP, geolocation, and all this kind of stuff. Is user using VPN and all this kind of stuff. You've set some of those rules, and then, all of a sudden transactions of maybe small ticket or high ticket size transactions are now flying around from the same user in some cases, from the same device in some cases. We've had cases where, you have a single device and you have rules that you've set conflicting with other rules, right? Jumping around. So a single device with a certain serial number or for Android, the code has been performing transaction, and in 5 minutes has been performing transaction like 5 different locations, right? All far apart, almost 100 kilometers, 1,000 kilometers apart within a very short period of time. You know that realistically that is impossible. So you've said things that change, right? IP can change, a couple of things can change, but you have to go beyond IP because in Nigeria, IP is usually rotated if you are using a mobile device, right? So if you are using MNO, your MNO will definitely change your IP every few minutes, right? So you sustain it, and then when you move around and disconnect and reconnect, your IP changes over time. So we had said things like that are would normally change, but we're seeing repeated fraudulent transactions from those rules that we have set, right? So I would say that that's like the bare minimum that, I can definitely state right there on this call, right? Other things are, location spoofer and so many other things that, users use in a sense.
Amazing. So I think we've gone into the more like location-specific data, talking about how IP and I guess there's some geolocation data that you're using as well to just kind of detect what may be defined as fraudulent behavior. So thanks, Wale. I don't know if anyone else, Abuzar or Stephanie, if you want to take a stab at this one.
Stephanie too.
I'll let Abuzar take it now.
Yes, so I just wanted to add to what Wale said. He did cover a lot of the some of the data points that would be useful. On our end, we work with AI and machine learning models, quite some more sophisticated models, and so the sort of models that we work with, the more data points that you can feed into it, the better the performance of the model becomes. And in addition to the, Wale actually talked about a lot of those data points. Some of the data points that we feed into our machine learning models are behavioral biometrics. So that includes like how you interact within the session, when you log in, when you conduct the transaction, what is the amount of time that you take between the different transactions, in between transactions, what else you do, how do you interact with your application. There's device information, as was mentioned. What sort of device are you logging in from? What is the specifics of that device? There's user information, for example, where's the user logging in from, etc. What's their demographics and all of that. There's transaction information, which includes, what was the user's balance before, what amount are they moving, how does this amount, for example, differ from the regular amounts that they move, the times of the day that they do transactions, how is it different than this particular transaction. We look at network information, which includes like IP address, etc. And then obviously, locational information to look at, what sort of locations are you logging in from, what sort of channels are you using, is this a point of sale transfer? Is this, for example, a cash out transaction? Is it an ATM or is it a bank to bank transfer? So, what we do is that we feed, all of these variables, which, in our case, frankly, it's like hundreds of different variables that are then pre-processed into like many more into the AI model. And then the AI model is what intelligently basically picks out, does pattern recognition to understand which transactions are fraudulent and which ones are not. But yeah, so in our case, the more variables you have, the better the performance of the model becomes, even though obviously you need to there's a step of like pre-processing where you need to understand how your variables are interacting with one another.
Yeah, I think you laid it up like perfectly for Stephanie to just, I guess, finish the goal on this one. So Stephanie, data points, and I guess like an additional question for you, Stephanie, would be about kind of data structures that companies need to have. Like, can you just speak a little more on what kind of structures would kind of help, or should companies have for them to be able to take advantage of some of the more complex machine learning applications that we're discussing?
Yeah, so Wale and Abuzar obviously covered a lot of variables. I'd also say that one of the strongest data points you could also have is external variables as well to your system. So say there's a scenario that you onboard, say for example with Paystack, we onboard so many merchants ourselves. So say the majority of your merchants are budget airlines, but now you've onboarded a luxury airline. If you just kind of use your own kind of data to inform whether something is fraudulent or not, there's a chance that you'll end up with lots of false positives, because now you've like put in an airline that's got completely different characteristics in terms of their transaction history and behavior to the ones that you're grouping in with that. So you can employ something like clustering. You can even create your own kind of like data from the data using machine learning. So kind of customer or merchant segmentation. And putting in those behavioral kind of metrics as well that you can then use to inform your fraud model down the line. In terms of data structures that can be required in order for you to be able to implement AI, obviously you'd need some level of real-time data aggregation capabilities. So for example, having cron jobs that are able to, over time, kind of count the number of transactions that are happening, what's the frequency of transaction behavior, how many minutes since the previous transaction, being able to store that data and then actually use it in real time to implement these models. So it comes with a large amount of investment financially, as well as kind of resources in terms of personnel to monitor the situation, ensure that your data is correct, that nothing's going wrong in the system before you're making your decisions. And then the beauty of the whole thing is you don't want to impede the actual transaction duration. You don't want to increase it to such an extent that you lose your customer in the process. So it's a balancing act between what are your resources. Is it an opportunity that you find the right kind of product for you that suits your resources whilst enabling normal transaction behavior? So it's kind of like a bit of a tango. And I'm just thankful that I'm not a CEO myself and I don't have to implement these systems, because I wouldn't even know where to begin.
Yeah, I guess that one is for Wale and Abuzar. I wonder how people are able to make those kind of decisions, especially when you have like such limited information to go on. Thanks a lot, Stephanie. So I guess something just to kind of help everyone understand some parts of what we're discussing. So can we speak a little more specifically about the kinds of models that we work with? Because I know like on the subject of machine learning and artificial intelligence, there's like specific algorithms and specific types of models that people choose to adopt, and also kind of the type of model you choose depends on the kind of solution, the kind of problem you're trying to solve. So I guess just for everyone in the room, can you just speak more specifically about maybe a type of model that you've worked with, and maybe if you can share as well, like what kind of problem are you trying to solve? Yeah.
Yeah, happy to take a stab at this.
Okay.
Yeah. So, overall, when we talk about machine learning and AI, now, they've become like buzzwords. So, everybody uses them in different contexts. And usually right now, the understanding of AI is generally of generative AI, which is what, ChatGPT like popularized the past couple of years. But, AI and machine learning goes beyond that. So it's generally, machine learning is that ability for the computers to learn on their own without specifically being programmed to do something. And so, within that, there are different types of machine learning models. Like, for example, there's supervised models, in which you're basically telling the computer what sort of an output you want to predict. So that way, for example, you want to predict the price of a house. So, that is supervised learning. Within that, there are multiple different, models that you can use. For example, linear regression, the most simplest form, to like decision trees, gradient boosting, etc. Then there's a category of unsupervised models, which is more where you are not telling the computer what sort of label you want. Instead, it's more of a job of like clustering. So you're asking the computer to do groupings based on the variables that you're providing it. And so this is usually used in like recommendation systems. And then lastly, there's like reinforcement learning as well, which is where you're letting the machine learn from trial and error. In this, the best example is chess. So for example, you're just allowing the computer to make moves, and then based on the feedback that it gets, it learns itself. So all of these are the different ways that the different types of machine learning models. For our particular case, when we talk about fraud, we generally, it would be a supervised learning model, because we know what sort of cases of fraud have happened in the past. Those are the labels. And we want the computer to predict what sort of fraud, which transactions are likely to be fraudulent. So there, you can start with very simple models like linear regression, logistic regression, etc. But you can then also go to more sophisticated models like gradient boosting, like deep learning, for example, neural networks that will allow you to process much more information to build more complex models. Overall, your model depends, the best type of model depends on the size and the sort of data you have. So if your data set is like in the thousands, it's generally best for you to do like a regression model, for example. If your number of variables is, let's say 20, 30, again, you can use some of the simpler models. But if you have, millions of data points, if you have, thousands and thousands of variables, then it's best to transition to like a neural network-based system, because they work well in the presence of bigger amounts of data. So that's, those are all the different types. There is, when we talk about some of the state-of-the-art machine learning models. We're generally talking about neural networks or deep learning, which, in that case, it's, we've seen this in natural language processing and computer vision. We see it in recommendation engines and speech recognition, right? And so within the deep learning models, it's the computer that basically built the different features. It has a set of neurons in the middle that actually decides how to build the structure to best predict the outcome that you want. So generally, when we talk about fraud, the more data that you have, it's better for you to transition to more complex models. So because they can do better pattern recognition, they look at, you feed it millions of data points in the past, you tell them like these ones were fraudulent, and the computer then decides, the algorithm decides, for example, based on the patterns that I've seen, this is the most likely pattern for a fraudulent transaction. So that's, when it sees a new transaction, it can accurately tell you if it's fraudulent or not. I hope that answers some of the question, but Stephanie and Wale, you guys also you have a lot of experience in this, so please jump in.
Yeah. Thanks for the intro. So I guess Wale, you can go next.
I think Abuzar did a great job outlining it and making sure that everybody kind of understand it, right? In our own case, one of those things that I think we started with was regression, right? It's the easiest one to actually come in, see the pattern, you see all of those things, you kind of like lay it out, which is very straightforward, right? We had a team, again, we were more or less like we could do anything in that instance. And that was in 2019, yes. In 2019, we started with regression, right? We did some regression analysis on our data. Lucky for us, we were collecting almost everything possible, right? Again, in accordance to NDPR and GDPR, right? We were collecting as much data as possible from users. Of course, user are supplied, I think just like Stephanie said earlier, and then non-user supplied ones, right? You have to make sure you have all of those and then capture as much as possible. You would eventually need it. In 2017, 2018, we collected data from as much users as we needed at that time, right? Including data points that we don't really need at that point. But in 2019, 2 years after, we needed those data points badly, right? For our pattern detection and all this kind of stuff. So we did that. And the unique thing for us is we're not dealing with just payment fraud, right? We're dealing with loans, credit, right? Which is more difficult because this is your money going out to people that you've never met before, right? And you have to make a decision within 5 minutes. We said our 5 minutes is our 5 minutes, and we wanted to do it within just a minute or two, which is almost instant, right? So we had as much data as possible, and we wanted to predict what is going on. We had problems, right? We're not going to shy away from that. So we couldn't get some components right? People of color, again, face could not be detected, so many things. We had to talk to different providers in itself, right? And when we did that, one thing that we realized was that except you have a professionally taken picture, most of the ML that was out there in 2018, 2019, we're not going to recognize you, right? We tried Google Vision, Azure, we tried AWS, right? Recognition and different products that we tried at that particular point. None of them got, I think the best we got was probably 35% in terms of confidence score. We got about 35%, and then we had to approach the 3 of them, right? And then said, you have errors or issues with your model and all this kind of stuff. We were lucky to kind of like work with Amazon to kind of like correct that. And then that was our first step in collecting more facial features, right, from customers. We wanted to see the structure of face, the color of eyes, color of ears, different things, right? And then we built out liveliness, right, in itself as early as, I think, late 2018, when we eventually resolved that. Then moved into open your mouth. We were telling customers to open their mouth, close their eyes, and all this kind of stuff. And then, we're more or less like patching those things together, right? There wasn't anything in the documentation that could resolve that. But having relied on that particular part, we had to move further into, okay, we've gotten all these things, right? Region of the eyes and all this kind of stuff. What do we use it for, right? And then we moved into graphing, right, in itself. So we wanted to predict, like, a new user coming in, would that user default or not? Is that user fraudulent or not, right? Because every user is very, very important to us. And, providing credit, speed of light in our low trust environment, in our country, Nigeria, it's a lot, right, to deal with. So we had to go into graphing and look at, graphing is like, you are on LinkedIn, you see first connection, second connection, third connection, different type. It depends on how far you are from the original node, right? So we looked at that, and that gave us a lot of insight into, where issues are coming from and then actively predict a customer that will likely be fraudulent in itself, which is like the key component for us, right? And that actually, we were so comfortable to the point that we were more or less like we had a dashboard that could tell us how much we were going to lose, right? Within like yesterday, how much we were supposed to lose due to like fraudulent users, right? Total number of fraudulent users that signed up, total amounts that they would have qualified for, right? And then, went from 10 million to 100 million to 200 million and all this kind of stuff. So we had numbers for that. We were able to see that. Each of our team members were able to see that, right? And then that gave more confidence for them to go into building more models, right? That actually has evolved. Like I said, it's been like 7 years of building different models, right? And we're able to get at least something out till now. So yeah, I think I will just pause it and then leave Stephanie to probably chime in.
Yeah, thanks a lot, Wale. Stephanie, I wonder if you want to add anything to models, solving problems. Yeah, over to you.
So I think it's pretty well covered so far, but I just add into the equation that it just also depends very much on your resources as a company, and also the nature of the data that you're collecting in the first place. So as Wale was talking about images and video, possibly video evidence as well, there's some models that can take that into account quite easily. So a neural network can also take image kind of like data into its into consideration and then output a decision partly based on that image that you input into the system. Whereas something like linear regression, for example, you'd have a very hard time trying to translate that image into something that the linear regression model could then understand. I'd say the other thing as well is like trying to get buy-in from your business as well into kind of machine learning. That's a common obstacle as well. So what you might end up doing is just choosing something that you can do with your own kind of resources and then scaling up. So the way that Wale was talking about implementing regression first, and then kind of like increasingly increasing the complexity of the machine learning systems that they were implementing. So, for example, you've got a CTO who isn't particularly forward-thinking. I'm not talking from experience, but saying that there is such a person and they don't want to put in any resources whatsoever to get you off the ground in terms of machine learning in the first place. What you could do yourself is just implement a very simple system. So say like a decision tree classifier, something that is also human interpretable. So some of these models, they're a lot more easy to translate into something that humans can understand than others. So neural network is essentially like a black box. It's essentially trying to be a mind reader. So it's built on the kind of whole kind of like structure of the human brain. So if you think into like why your mum makes the decisions she does, it's kind of hard to like actually track that thought from the beginning to the output. Whereas if you go down like a decision tree, for example, you can see because this says A, then you go down this branch, and then because that says B, you go down this branch, and then eventually you can add all those rules together and come up with an idea as to why something was rejected or allowed in the first place. I'd also say that no model is perfect. So you've got some models that are more prone to certain errors than others. So you can have issues with overfitting or underfitting from certain models. Abuzar also talked about the fact that certain models can't take on more than a set number of variables, otherwise they really start to struggle. And then the other issue as well is just how many variables do you actually want to put into your system? There's a whole kind of iterative process to understand what you actually need to put into your model, so that you're not actually overloading it with unnecessary information as well as the necessary information that you require. And then add into the mix that your fraudsters are constantly changing their behavior as well. So you don't want something that's not able to dynamically respond to the latest kind of fraudster behavior. So again, where you've got like a decision tree, for example, how often are you retraining that decision tree to make kind of the right classifications of fraud and no fraud, compared to if you have a neural network, are you able to train that quicker? Is it able to respond quicker than a decision tree to what's just happened in the last half an hour, 1 hour, 2 days? The other thing that I wanted to talk about as well is just the cost versus benefit. So if you're in an industry, for example, that has a low rate of fraud, then maybe a neural network is kind of like a little bit overkill for what you need it to do compared to the costs of actually running all that data, running those calculations, being able to process all of that data compared to if you've got a fraud rate of like 0.00001%, maybe a decision tree is right for you. So it's always responding to how are fraudsters actually behaving on your platform and then responding to it in an appropriate way.
Yeah, thanks a lot, Stephanie. I think you already just kind of dipped into the next thing I was going to say. So I think this is directed specifically to you, Stephanie. So just very quickly, pros, cons of just choosing to use machine learning to solve the fraud problem. What would be your pick? Maybe just 2 or 3 of them.
So I'd say a definite pro is that you can technically be one step ahead of your fraudsters. So if you've got the static rules, they're going to learn the static rules. And I think also statistically, there's a lot of interoperability in terms of like insiders who are also like basically telling the fraudsters how a business operates. So the more complex those rules are in terms of identifying fraud, the harder it is for someone to even communicate what those rules are to a fraudster outside of the system. So I'd say that's a definite pro of machine learning if you choose the right model. And the second pro that I go on as well is obviously the accuracy element of it. You want to ensure that your customers have a good experience in your platform, that they're not needlessly being blocked from trying to make a legitimate transaction. But also conversely, that a fraudster can't take advantage of their information or can't take advantage of the platform itself. So it's a balancing act that I think machine learning is best poised to solve.
Yeah. I guess maybe Abuzar can take, or Wale, I don't know who wants to go for the other side of the argument. So just like cons of using the machine learning models to kind of solve the fraud problem.
So on that end, actually, I don't see a lot of cons of using machine learning if you can build them right. The con could be if you don't know how to deploy them properly, if you don't know how to set up the infrastructure, how to test for example for bias on the data, etc. If you don't have the capability, then you can build a model that's bad. And an example of that is, think about fraud, right? Out of 100 transactions, maybe 1 is fraud, and even that's overstating it, right? If you build a model that says every transaction is safe, you technically have a 99% accuracy, right? Because you've predicted it correctly 99% of the time. But in reality, what you've done is that you have not predicted the one transaction that was going to cost you, thousands of dollars. So this is, an example that if you don't know how to build the right model, then it's better to stick to the rules, because your rules could have picked out maybe that one fraudulent transactions. But, other than that, there's generally, the machine learning model is much, much better than a human, because any human can only analyze at best maybe 10 to 20 variables at one time, right? If you're thinking about all the different variables associated with one transaction, a human brain cannot really comprehend more than 10 to 20 variables and then work through all the possible combinations of those. But with a machine learning model, it's much easier to do that. So that's why there aren't many arguments that I could make for non-ML model over an ML model.
Yeah, I think I walked right into that one. I don't know why I didn't see it coming. Wale, do you have anything to add? Because I want us to just move on to the next thing if no one has any cons for.
No, I think Stephanie already said it. Could be expensive. Again, I think Abuzar also said it could be expensive depending on the size of the company, right? And then, the resources that are available. So I think they've put it really well.
All right, perfect. So because I'm going to go into a more divisive topic, which is, do you choose to build a machine learning model solution, or do you choose to buy, right? And I think in 1 minute or less than 1 minute, if possible, I'd just like to go around the room. I guess we can start with Wale. So less than a minute, build or buy. What side are you on?
Must it be one, or can I make argument for both?
No, you have to choose definitively. I'm sorry.
So from my perspective, right, and it's the sector that we're in, right, it's more effective for us to build, right? It's a long-term investment for us, right? And we've seen the ROI, right? So I would go with build. Yeah.
All right. So I don't know who wants to go next. Abuzar.
I would say built, and that's obviously we are the provider of transaction monitoring solutions. But there are two reasons that I can mention, and hopefully I can convince Wale and Stephanie and you guys at some point. The reasons that I would mention is, one, the cost of building in-house. So you need to generally hiring data scientists, building the infrastructure and all of that can be very costly, and it detracts from your core mission of building financial services. That's one. And then the second, actually, and more importantly, it's that if you build it in-house, you're only using the data that you have access to. But fraud is something that it's better solved with more partners. So if you buy, the good thing there is that you're not just benefiting from your own data, but also the data of all the other partners that you work with. So for example, now when we work with banks and fintechs, what that does is that each one of them benefits from using our solution because the models have learned from everybody's data. So that's why, in reality, you can be far ahead in that case than if you're trying to just rely on your own internal data. So that's why, my argument, again, I'm very biased on this, is on the side of, definitely buy from Pastel.
Yeah, I definitely saw all of this coming, but so Stephanie, I guess you be the tiebreaker in this one. So
I don't think I'm going to be a tiebreaker. So I'd say that just it depends who you're buying from and whether they've got exposure to the same kind of part of the market that you're in. So, for example, a lot of the solutions out there, they're catered towards an American or a Western European kind of context. So if you buy from them, they're not going to have the Nigerian context, for example. So it's like buying from the right person who's got exposure to the right data, who is able to customize their product as well to your company. I think, in terms of building, if there's not enough of that kind of catered to your market, then you might end up being basically forced to build your own product. The other kind of element of building as well is if you have a high market share, then you'll have also more kind of exposure to that similar kind of, say, for example, Stripe with their radar. They've got exposure to so many different industries from so many places across the world, and they had the resources available to actually build it themselves. That makes sense. If you're a fledgling kind of business that's got a very small exposure to data, very low experience, doesn't have the resources of data scientists or data analysts or whatever to build this solution in the first place, then buy, I'd say.
Oh wow! So we're living here. We're living it in a tie. Is that what you're saying now?
I'm trying to make sure we're all friends by the end of this.
Okay, all right. So I guess I would not be voting because I would definitely be a tiebreaker. So I guess one point for build, 1 point for buy, and Stephanie somewhere in the middle. So thanks a lot, everyone. I think we have just a minute left. I wanted to see if we could take a question. So I can see there's a question from Oluwasegun Peter. It says, when you said restricting transactions based on IP addresses, how possible is that, as IP addresses are dynamically assigned? I suspect this one is probably for Wale. Why do you want to take this?
So again, it's not restricting, right? One of those things is, it's just one of those things that you are picking as a data point or data set in your decision, right? So it's not absolutely this is the only thing, it's because of IP that I'm going to limit this transaction, right? Like I said earlier, I said MNOs rotate IPs, right? And I said that, and you can't rely on just, IPs alone, right? But, device, combining with other data points, right, would definitely help make an absolute decision in that.
All right. So I guess now we're at time. So just final words from everyone. I guess starting with Abuzar. Just a few. Do you have any closing statements for the house? Yeah.
Yeah, absolutely. On the fraud side, it's very exciting to see, the number of companies, banks, fintechs that are focusing on bringing financial inclusion to the underserved, especially in, different parts of Africa. And so it's great to see that. However, one of the biggest issues, as David has pointed out, is fraud, and that's why we've been focusing on it. Unfortunately, that creates our environment where it's not easy to scale, it's not easy to build, and you lose a lot of resources just trying to fight it. And so that's why, it's something that every financial institution needs to take seriously. And then besides that, AI is the future. AI is going to revolutionize a lot of and that's our thesis at Pastel, that it's going to revolutionize a lot of the industries, especially the financial industry, because the pain points are so big and because every single human being needs some sort of financial services. And so that's why, I'd say that it is good to be caught up on the latest trends there, to follow up on how things go. And more importantly, I would also iterate on what Stephanie mentioned, which is that there's a need for solutions that are actually built on African users, on African transactions for the African context, because right now most of AI and ML models are actually built by Western companies that are training their data or building for use cases outside of Africa. And so that's why that also becomes important. So, and we at Pastel, that is our goal, to bridge that gap, to build AI solutions that are specifically for the African continent. But overall, that AI revolution is already here, and it will transform a lot of the industries.
Thanks a lot, Abuzar. Perfect. So Wale, over to you now.
Yeah, thank you. And thank you, Abuzar. I think you already laid ground for some of this. So I would say that, collaboration is another thing, right? Let's share data because fraudsters kind of collaborate on the other side of things. That's why you see clusters of transactions coming from a single place or coming from a particular source, right, that is located in a particular region. So I would say, as financial institutions or OFIs, right, let's collaborate in sharing data. When we do that, we limit the extent of fraud that is able to permit within the ecosystem or within our region. I would say AI is already here. And again, a lot of decisions, recommendations, and all of those will be solely based on that, right? And it's good that we are building for that. We'll be releasing some interesting products in the next few quarters coming up. So thanks.
All right. So Stephanie, just wrap us up, and I think that'll be.
Yeah, I'd just say that whilst AI is amazing, just make sure that you've got the right foundations for AI to be successful in your business. So ensure that you've got that accuracy, that you've got that completeness, and you've got an understanding of how your own business actually operates and your own customers and how they operate.
All right. Perfect. Thanks a lot, everyone. I'm trying to see if we have any other questions that we can answer live, but I guess I can't see anyone right now. So thanks a lot, everyone, for joining. Again, this event was hosted by Paystack as part of our Fraud Awareness Week lineup. You can just check all our posts and all the content that we've been putting out during the week on the hashtag Fraud Week. And once again, I'd like to say thank you to all the panelists. You guys are amazing. Thank you for showing up. Thank you for bringing your A game. We really appreciate the efforts. And I guess I'll be looking forward to settling the tiebreaker at some point. So build versus buy. We'll be back. Thanks a lot, everyone.
Thank you.
Yeah.
Thank you, everybody.